Hello. So what we're looking at is trigonometric functions, and we're looking at their transformations. So we can see here I've just started with our basic function y is equal to the sine of x. All right, we're going to add, I've written it out in blue and green here, sorry, and I've just added a slider. So we're looking what happens when I put a coefficient in front of the sine of x. So when a is equal to 1, it obviously just stays the same, but as I increase a, what you should see is that the amplitude of the graph increases. Now if I go down, so actually no, let me just stop on a whole number. So we can see when a is equal to 2, the amplitude is 2. Now if I go to the negative, let's start at -1 to start with, you'll see the amplitude is still 1, so the negative isn't affecting the amplitude. But what it has done is reflected the graph about the x-axis. All right, and then you can see if I continue to go into a negative, go to 3, if I can get it to 3. All right, you can see if I zoom out. So if a is -3, the amplitude is 3. All right, so that's that one. All right, let me put that back to 1 and let me add another coefficient in. So this time I'm going to add a b in front of the x. All right, so let's see what happens when I change the b. So as b increases, you can see the graph is compressing. And if we get back to 1, what happens when we get less than 1? You'll see the graph stretches out. If we get to 0, it becomes a flat line because a times sine times 0 is 0. So your graph effectively becomes y is equal to 0 there. And as we go to a negative, you can see the same thing happens. It again compresses, but we're actually more interested what happens when b is greater than 1. All right, if I get it to 2, let me see. Okay, what we can look at here is if we look at one cycle of the black graph, if you now look at the green, you can see it completes 2 cycles in the same interval it took the black graph to complete 1 cycle. So the variable b, actually as it increases, you can see more cycles of the graph are completed in the same interval it took to complete 1 cycle of our original function, which was y is equal to sine of x. All right, so let me put that back to 1. All right, now let's go back into this and add another variable. This should look familiar. All right, add slider C. So you can see, let me put C as 0 so we can see where we're starting. Okay, so this should look familiar. Looks like the quadratic functions that we were playing around with. So now as I increase C, so as it becomes a positive number, so when C is 1, the graph moves 1 unit to the right. Think about that in the equation. It would be still written as x take 1. So take 1 inside the brackets moves the graph 1 unit to the right. If I go to -1, inside the brackets that would be x take -1, which is x plus 1, and the graph moves 1 unit to the left. So it's doing the opposite to the sign inside the brackets there. Okay, and if I continue that, you can see as I decrease that number, it keeps moving to the left, and as I increase the number, it keeps moving. Sorry, did I say the wrong thing? As I increase it, it moves to the right. As I decrease it, it moves to the left. Let me get that back to 0. Oh, I can't find 0 apparently. Okay, and let's add one more variable, and that is a constant on the outside. So plus d. Add the slider, and you can probably guess what's going to happen here. All right, when it's at 0, let's see, get it to 0. Okay, so at 0, we can see it's the same as our initial function. As I increase d, the graph translates up. So 3, you can see it's moved up 3 places. Same if I go down, it has moved down 3 places. So hopefully that's not too much of a shock, and you can see the connections between all the other functions we've already learned.